All right. Good afternoon, everybody, and welcome to 6G Resilience panel. My name is Matti Latva-aho, and I'm director for 6G Flagship program at University of Oulu, Finland. 2 more weeks, and then new duties are ahead of me after that. We have a great panel set up for this afternoon. If the clicker starts to work, I would show you even. So we will have a great spectrum of different background people. We have David from Public Safety Communication Europe. We have Mikko from Nokia Bell Labs Finland, Aki, XGMF and Tokyo University, Hannu, NATO Diana 6G Test Center Finland, and Tommy from Chalmers University of Technology. We will try to cover quite broad aspects related to mobile networks resiliency. And when we started to think about in our 6G flagship program that what might come the next big wave after 6G is done and standardized, we came up with lots of ideas coming from serious and important societal needs. And sustainability, of course, AI-driven society, but resiliency has turned out to be one of the really the most important topics that we could come up with. It hasn't been addressed strongly enough so far. Mobile networks were not meant to be that important part of critical infrastructure when they were established a long time ago. It was a kind of a luxury product, more or less. It was not meant to be everybody's pockets and so forth. Now it's time to start to look at different aspects related to mobile network technologies, as they are so critical to all sectors of modern societies. So there are lots of things that we should establish. We should get our hands dirty right away. There are lots of things that are short-term and medium-term, long-term. We can set our minds free, and we should go to these crazy ideas as well as Erik Ström put it nicely in the morning in his keynote. So we will try to discuss these short, medium, and long-term aspects today. There are issues related to national regulation that can be done today in existing technologies. We don't need another G to start these things happening. 6G standardization is starting this year, and we as academic researchers, we should keep more noise of the importance of mobile networks resiliency, so the standardization process is not neglecting it. It might be that 6G standard is driven by the same target, same forces it has always been. Throughput, capacity, improved capabilities of networks. But resiliency is, in my opinion, far more important than increasing capacity. Long-term research, we researchers have to set our minds free, and we start to think about what we call resilient by design aspects, where AI ML algorithms might be a nice playground for coming up with interesting novel ideas, how to make a network self-healing, self-understanding, able to come out from difficult situations that they were never planned against for. We will cover lots of different questions in this panel, from technology, interdependencies of critical infrastructures, standards and regulation. We will discuss as well a bit softwarization aspects, and also what is the business case for mobile networks resilience. Now I think we will introduce our talks, everyone one at a time. You may actually come to stage already now, or you can come also in the order of your presentations if you wish. So David, you are the first one. Can we have the next set of slides, please?
Thanks a lot, Matti, and thanks for inviting us to speak here. Unfortunately, my legs are not as resilient as they were, so I have to walk in stick, you know. But it's all about figuring out if something is not working so well, or you expect it to not work so well, then put provisions in place, I would say, to make sure that those systems do work under stress and pressure. On the slide there, we're going to talk about the European Critical Communication System. Sorry. Okay, thank you. And this is a program we've been leading from Public Safety Communication Europe Forum for about 10 years now. And we had a surprise last year that as the European elections happened and President von der Leyen was re-elected, she put a priority on there about establishing the European Critical Communication System by 2030. And recently, about a month ago, the Protect EU internal security strategy set that in stone. So we have such a challenge ahead of us to implement this brilliant, resilient mobile communication system which works all of the time by 2030. Do you believe it? Yeah. I'm not quite sure, but we've got the target. We're going to try and reach it. On the slide there, you see the diagram at the top, because originally the diagram at the top is responders moving around Europe. At the moment, they cannot be mobile and communicate because they're using a 2G-related technology, tetrapole, and they cannot cross a border and communicate. What we need to achieve is, we call it operational mobility, the ability to carry out their operations wherever they are, whenever they need to, so there's your resilience factor, and cooperate and communicate with whoever they're tasked to cooperate. So actually, responders should be able to cooperate with their responders from their neighboring countries. It happens a lot. I have colleagues who work on the border of Czech and Bavaria, and they have some real challenges there, not just with the mobile communication technology, but also with languages and things like that. So you see on the bottom left, that's the one that shows the picture today. In the middle, we're looking at a mission-critical, capable, resilient mobile communication system in each member state. Once that's deployed in each member state, then we interconnect that, responders can roam. On the right-hand side, you'll see one big antenna. That's not realistic, but that's how the responders need to see it. Okay, public safety responders working together, using their mobile device, not getting in the way of what they do best, fighting crime, saving lives, fixing people, picking them up. But they need hands to do that. And they need a resilient communication system to call for help when they need the help. So here you'll see the resilience factor goes across all layers of this system. I typically use the TALT model 2003. 3GPP is the bottom two layers of this diagram. A mobile communication system, any communication system really does use all of those layers. Operational mobility is towards the top. Information exchange there in the middle, knowledge awareness is the key. So actually sharing information with their colleagues so that they can jointly react to a disaster is key, information exchange. But the mobile communication underneath it is just pretty much the way that information gets from A to B, or A to B, C, D, D, because it's group calls. And all of this needs to be resilient, available all of the time. As I said, operational mobility is about being able to communicate anytime you need to, wherever you are. So there's a challenge for the 6G community, because at the moment, mobile communications are deployed as best effort, as far as we see. And what happens in a rural area where there's no business case to deploy a base station? Maybe NTN might solve that. I don't know. We'll see. What we did a couple of years ago, and trying to understand the goals. So PSC, we run a conference twice a year. We're quite aggressive with that because we'd like to get all the ideas together and discuss it and the all network. So that's end users, industry, and researchers. And we had a workshop, or 2 workshops, all about what is it you need. So the guys from 6GIA said, well, we need to figure out what is it public safety needs from the future mobile. Well, actually, we don't care whether it's called 6G or not. We just need better than what we have today. And for us, we're going from a 2G world to a 5 or something else G world, several Gs. And that's quite a challenge for them. But what you see on there is a list of strategic goals: borderless networks, seamless availability, ubiquity, interoperability. Learning from experts on the scene, so it's actually building the system for the purposes of use. Real-time continuous monitoring so that we can see when something's going wrong. Rapid deployment, where there's some connectivity lost there, the resilience hasn't kicked in, deploy something there. Shared situal awareness is the key to all of this. And dynamic allocation of capacity, because when there's a disaster, there's lots of communication in one area, networks become oversubscribed. Do you prioritize on public safety, or do you prioritize on the civilians trying to get a video to their family to say, yes, I'm okay? There's a lot of challenges and balances to be made there. So in the connectivity, what are the underlying needs for connectivity? You can download this paper using the QR code, by the way. So working across diverse standards and applications. So 3GPP is a foundation for this system we're going to build. Of course, on the mobile communication level, but also on the mission critical service level. We're leveraging mission critical services, which are recently standardized. The maturity of the technology, we're procuring that technology as testbed level and trying to understand how mature that is and how it can be interconnected. The standards are not fully complete. We're going to have to fit back some of the standards and probably do that through ETSI, not necessarily through GPP. Complex environments. We need to improve the infrastructure. You know, a couple of weeks ago, there was this massive power outage in Spain and Portugal. You'll have seen that on the news. I was interviewed by CNN for that. And they asked me the question, so what's the impact on public safety with this power outage? And my answer is, well, typically, in the tetrapole networks, and it's tetrapole in Spain, they have power backups behind them. So they have enough power capacity to keep the mobile communication going. And then I asked my colleague in Spain, who leads that system, and he said 75% of their tetrapole base stations carried on working because they had battery back. But they all lost the interconnect to their core network. So they were all in isolation mode. So the responders in the current area could still communicate with each other, but we couldn't communicate with other systems further away. So the resilience is not just about the mobile communication base stations and things, it's also about the underlying network behind that. We have a challenge with EuCNC to build not only individual core networks in individual countries, but also to securely and resiliently interconnect them. That's quite a challenge. And it's just a picture of the fact that we bring real responders to play with the tech. Last week, we were in, like I say, we were in Stockholm. We had 60 responders running around the field pretending to capture some drugs thieves. And it was quite good fun. I'll leave it there. Thanks, Matti.
Have a seat there.
Yeah.
So next one is Mikko, and he will talk about resilience aspects studied in HEXA-X2.
Thank you, Matti. Thanks for the invitation. So, yes, Mikko Uusitalo, coming from Nokia Bell Labs Finland, have had the pleasure to lead the European level 6E flagship HEXA-X2 and telling then about observations from HEXA-X2 point of view. Regarding especially resilience. In HEXA-X2 we have been developing more than 100 enablers for 6G, and then with getting this together we have formulated this end-to-end system view and architecture. And when we were building this we put up design principles and top priorities for building this end-to-end system view and architecture. And as you can see, principle 5 here is resilience and availability, so central item. We recognized system requirements. We were combining mostly resilience together with security. And in this resilience and security area, redundancy was considered important, different kind of self-healing mechanisms that can then automatically react faster than than some human-based observation and action on that. Then safety, the security cryptographic protocols, as well as then possibilities to run the computing in a confidential way with respect to the data being computed. And AI-enabled automated responses is related to self-healing mechanisms as well. Then here you can see this overall picture on this end-to-end system view with different layers, and I'm not going into further details of those, but bringing attention to these pervasive functionalities that cut across all these different layers. And then there we recognize the need to host some functionalities, and one of the central ones is this security, privacy, and resilience. So all of those combined together. With the security, privacy, resilience controls featuring confidentiality, integrity, availability, authentication, authorization, privacy, and resilience. And then cutting across, as said, through all these layers, and with the system level resilience provided by ensuring closed loop automation. Then we were looking at the overall approach from the point of view that what kind of enablers are needed to contribute to this security, privacy, and resilience. So those you can see here first, and then on the other column you can see then enablers that were developed that then rely, in order to carry out their functions, rely on the security, privacy, and resilience controls. And on this enablers supporting the security, privacy, and resilience, you can see lots of examples. Examples here related to different ways of recovering data, protection of data, different methods for guaranteeing and maintaining the connectivity, as well as then machine learning based operations related needed additional functionalities to joint communication and sensing protocols, trustworthy radio solutions, and then secure and scalable architectures tailored for trustworthy AI/ML in the different parts of the hardware, as well as then in the management and orchestration several new functionalities. So collectively, these provide a unified framework for enhancing security, privacy, and resilience. Thank you.
Thank you, Mikko. Next we have Aki. Do we have the slides? He wants you to talk about XX. So this is the this is still the wrong set.
Okay, good afternoon. I'm NAKAO at the University of Tokyo, and also I'm a co-chair of XGMF. Before I start my talk, I'd like to explain a little bit about XGMF in Japan. So we had 5GMF, 5G Mobile Network Promotion Consortium, and after that we have a Beyond 5G Promotion Consortium. But now we have XGMF. We formed this last year, April, and so this is the contact window for international collaboration in Japan. And the reason why we are calling it XGMF is that we have to take care of the 5G monetization. We still suffer from deployment and the monetization of the 5G infrastructure, but at the same time we have to push the 6G R&D, and so we are calling it XG. X stands for 5, 6, not 10. So people are joking about Japan started 10G already, but we're not doing that. So, and the Matti told me that, we should be limited to 3 slides. We have lots of text in my slide, but I don't read out everything. But in terms of resilience, I have to tell you that Japan, we are living next to a natural disaster. And for example, we have lots of examples to talk about when it comes to resilience and against these natural disasters. And I'll give you, last year in New Year Day, we had a very big earthquake in Noto area, and 241 people got killed in this incident, and we didn't have telecommunication available in that area. And that's the main reason why, these many people got killed, because we can't contact their families. And especially, it was a New Year, it was really bad, because lots of people went, hometown, and then they got killed there. And also, 14 years ago, we had, I think you remember that there is a big earthquake in the northern part of Japan, and there's a nuclear plant got nuked. And so we saw on TV news globally broadcast that many, not just buildings, but telecom infrastructure got destroyed completely. And in the Noto earthquake case, we used NTN already. The Starlink, the connectivity was available. So then all the nation realized that we need 6G technology, especially NTN. And we have not only earthquakes, but typhoons and floods hitting Japan all the time. So as I said, we are living next to this natural disaster. So this topic today, the resilience, is the many people's concern now. So as I said, resilient connectivity is part of our national emergency priorities now. And I can introduce a little bit of our government strategy, prioritize the APN, all photonics networks, and non-terrestrial network, NTN, and advanced RAN, including a local connectivity. And especially focusing on NTN, because NTN can extend the coverage, and even if telecommunication infrastructure in a terrestrial network got destroyed, we can still use the NTN for lifeline. Okay. And I think a core 6G requirements, I like to say that network for AI, because we say that telecommunication is a cyber lifeline for your protecting for your life. And also social economic activities, we all rely on the telecommunication. But now, so all of the people are now using generative AI, and I think every day now. And this access to this AI compute will soon become the necessity, and it's a viable application of the telecommunication. If you lose the connectivity to AI compute, so then that is the endanger your life and also economic and social activities. And seamless, talking about AI, so we have to have a seamless operation in natural disasters. We should be able to predict the disruption of the telecommunication by using the power of AI. And I think many people already talked about this AI, and also 100% national land coverages are integrated with the early warnings and public safety. So Japan is covered only 70% of the land by cellular telecommunication. But the rest, 30%, including the mountainous areas and ocean areas. Matti, in fact, came to Japan and we went to Mount Fuji. I think lots of people are visiting, climbing. I think it's like almost 100,000 people are going up there every year, but almost 100 people get lost there because of the loss of the telecommunication there. So 100% national land coverage is very important for resilience. I think we can enable that by NTN and terrestrial network integration. Okay, so and a dynamic spectrum sharing strategy. So we haven't worked seriously on that yet, but efficient use of spectrum is the next target that we should work on. And also minimizing the human errors and misconfiguration. I can tell you one incident that happened in 3 years ago. There's one, I don't name this teleco's name because maybe this is a problematic, but there is one teleco that got very serious disruption, and that hit entire Japan. And so almost 85 or 86 hours, we didn't have this cellular network, and it was really bad, and we lost. There's a huge loss in economy of Japan, but that was caused by only a few lines of configuration mistakes that the engineer introduced. Only few lines, and I think this teleco lost like 70 million euros by just the 3 lines of a misconfiguration, which could be prevented by using LLM today, because you can just put the wrong configuration, and LLM can instantly tell that there is a mistake in the configuration. Okay, so enough for core requirements. So I think technology enablers, so immediate technological enablers, I can see from Japan's standpoint is that the NTN, LEO, and HAPS. So I think we are introducing HAPS. 2 companies are working on this HAPS, and last year, this February, so there is one Space Compass and NTT Docomo did an experiment in Kenya, and so the HAPS can connect your phone successfully, and I think there are several mega BPS communication they enabled, and that was very good news for Japan, because we can use HAPS in a deserted area, and also the area that suffers from this natural disaster. And I already talked about AI-based risk analysis, analytics and routing, and APN for decarbonization. Okay, let me explain a little bit about APN. So this is Japan's strategy, as I said. So connectivity to AI compute is taken seriously in Japan now, and all photonic network to connect the data centers, AI data centers, so that everyone can get connected to AI. All the verticals can get connected by green, safe, secure, and reliable AI to the entire society through 6G technologies. But APN, all photonics networks, instead of laying out these electrical transfer line, which is very costly, but you can build the data center just very close to a power generator, like a nuclear plant. So then you can just lay out the fiber so that you can use AI, GPUs by optical lines, very low latency, low jitter, very stable. So as I said, access to the AI compute is a critical infrastructure now. So, of course, EuCNC is about wireless technology, but we can also consider connecting end-to-end, APN and RAN, and also NTN. So I'm getting long, so Matti is watching me, so just one more slide. So, can't do that. Okay, so this is my last slide. And there is an NTN group in XGMF, and we talk about a non-terrestrial network grant design, and which is no different from other organizations' picture, but HAPS here. in the middle, I think this is, Japan is seriously investing on hubs now, because you can fly over to the area where that is suffering from the natural disaster. And this is very, we expect this technology would be deployed maybe within this year or next year. Okay, and the right-hand side picture is that we are also interested in NTN and TN integration, and they complement each other with their respective strengths, like coverage, capacity, dynamicity, latency and sustainability. So, NTN and TN has their own, strengths. So we should be able to combine that to make a resilient infrastructure. Okay. End of my presentation. Thank you very much.
The next one we have Hannu talking about interesting things from NATO Diana 6G Test Center.
Okay, thank you, Matti. Indeed, it's nice to have this kind of opportunity. A little bit risk-taking from Matti that inviting me to here with my background. So I will talk about the 6G Test Center and how it is then linked to the resilience and what we can bring in there. We could actually put it this way, that the 6G Test Center is the combination of the extreme environment, dual use innovation, then resilient architecture, validating that and making the validation so that we enable and ensure that 6G is not breaking when it's biggest matter. So let me start it anyway, looking a little bit at how I see the 6G. It's not really only pushing the boundaries of the performance or capacity. I personally see that it's somehow the redefining the communication so that it's supporting the social backbone. So, and 6G is integrating quite a lot. I'm leading one of the vertical related of the defense, but 6G is really connecting this kind of critical vertical like defense, energy, and then healthcare. So we could see that if the failure is happening, some of those, it is cascading easily in the other ones also. We can say that resilience is not anymore in something that it's optional. It's really the mandatory to take account already in the day one. And day one means that it should be already think about it, the standardization, and then going to the designing. It cannot be really to bring afterwards in the designing then. If you look at it's also required the mindset change for us. It's coming this kind of performance-driven mindset to come really the resilient-centric architecture. I see that architecture is the one of the key here, and enabling then this kind of AI part of the architecture. We can distribute it to architecture when it's then bringing a lot of the capability there. Then, of course, as a 6G Test Center, we have one of the bigger initiative is this kind of hybrid network. We already heard it about how to utilize the NTN, and that's the one of the key also when we go in the areas where we don't have a mobile coverage. So how to use that? Software is coming really into the 6G time in the network, so it is bringing also the risk of the attacks. But then it also to bring the opportunities and then expanding the possibilities. So there the zero trust is really one of the key to make it happen. So in the 6G Test Center we validate, we created the environment and this kind of capability to validate this. Okay, so basically in the nutshell, our mission is quite straightforward. Dual use innovation for the critical industrial, whether it's the defense or some other of the area. We are able to do in the different kind of the commercial network. Part of that will be the mesh tactical network. Then we are also bringing the picture in the satellite. So that gives the good platform to really the look at how the theory will then come to real. We can prove that one there. In the NATO Diana, we are part of that. So we could say that strategically we are one of the core in the 6G and unique in that sense in there. So we are able to also provide it, that area in a way there's this kind of testing, evaluation, verification and validation support. And that's helped them to going then into the market. My background is heavily coming on business, so in the final slide I want to a little bit talk about it, the business opportunities. It can be always, that is the only the nutshell view that what we could have there. But I personally see that 6G time, it's actually bring a lot of capability into and business opportunity. We should really see the resilience and 6G in the one of the value generator. We talk about it, the AI, how is the network changing. We are talking about this kind of the joint communication, sensing where we have awareness of the environment. So I see that there's a lot of potentiality. Then it's about the security, and there's probably the companies who has already the compliance in the high level. So they also should see that as a competitive advantage for them. In the dual use game, it's the two-way that in the commercial side we can bring this kind of dual use solution or product, what can then enable the market more and improve in the resilience. But we can also think about it the other way around, that something in the critical infrastructure, what has been already defined there and designed, could bring some value then also in the commercial side. So in the 6G, you could think about it, how we can then improve the revenue or this kind of the growth. So basically we are the bridge between the industry, academy and defense or some other critical area. And we are gaining now when the innovators are coming, we are helping them to go in from the design to develop and this way in the market. So that's in my side, so thank you very much.
And last but not least, Tommi.
So good afternoon, and thank you, Matti, for inviting for this panel. I think it's a very timely and very important topic. And I think that this topic is rooted in the insights of what 6G has to come to support the mobile industry. We are facing a deep digitalization of society. We are increasing the dependability. So with that, we have high requirements on trustworthiness, but also supporting societal needs. And to that, we really need to have a big grip on what 6G is about. So here, I didn't do subsequences. Okay, you see all my bullets at once. Okay, so what I felt, I have two slides. And the first slide, I wanted to see if I can structure a little bit this topic. So to the left, you see I listed a few bullets on threats. And because I think if you should do some structured research and discussions on this topic, it's good that we have some structure. So from threats, we have threats based on failure from malfunction. So that is the implementation aspects. We have threats related to technology failures by design. And I put a dash and AI also there, because with AI there are things we don't know. If we start to have multi-AI interactions, we can end up with interesting behaviors. There's some recent research on that. So how should we handle that? And then we had the general risk of attacks on infrastructure, cyber attacks, and then attacks on enabling infrastructure, so power and everything around physical infrastructure provided by society. But on top of that, there are also other aspects. I'm in the board of the Swedish Telecom Authority, PTS, and there we talk a lot of resilience on the existing networks and how we should, what's the role of a regulator to follow up on that. One aspect of that is to scrutinize how are the operators working and the vulnerability on the organizations. And then we have all the natural disasters that Aki already highlighted, and I think it might be worse and worse in general in the world due to climate change. So how should we then measure and do science on resilience? So now I'm in the middle column. I think we maybe need to talk about different levels here, and also on the design. We can talk about the service level, because we can have malfunctions on different entities of a system, but where the service is still maintained. That is actually what's been happening now. We are hiding some problems. If you know, there have been some underwater cable problems in the East Sea, as an example. And some of those reports have not been done as malfunction in the connectivity, because there have been resilience in the lower levels. So I think we need to collect this kind of data on lower levels as well, and build this awareness and create models. So next level on the service levels is networks on networks. So there we can have resilience by design. And then individual networks on the site level. So particularly, do we have multiple equipment per operator, or do we do equipment sharing? Here we see a good example of trade-off on efficiency, from efficiency, cost efficiency versus resilience, if we share equipment or not. And then on the network equipment design and manufacturing quality. And on the supplier level, and then on this infrastructure level from the provided by the society and the operators. Then I have another column here related to dual use, and that, I think, column is also relevant for discussion related to blue lights or this kind of systems. So how much do we rely, how much do we dare to reuse mobile standards? How much do we dare to reuse the design and APR? How much do we dare to reuse hardware and software components, the equipment, the sites, the spectrum, the networks? And can we do it fully, or should we do it partly? So I think there are many design choices here, and everything about trust and the level of independence of these different networks and their needs. So finally, at Chalmers, we are working on what I call situational aware networking. Part of that is to do multimodal sensing and to create this situation awareness, and also add the dynamic network elements and network on networks. That includes 6G integration. So this illustration here illustrating we do our work together with UCI in California, where we model hazards in different ways, like flooding and wildfires and compound effects and their distribution, and how can we do a resilient network design around this offline statistical and online information. So.
Thank you, Tommy. Can I now have the slide set number 7, the last one? So I will go through some of these questions first, and then I would like audience to think about already something that we have missed, or you would like to challenge the panel. So we heard really different views and viewpoints. Really, as you already now start to sense that resilience it's monster big area. There are lots of things to be covered and discovered. It's a journey that needs to be started sooner or later, so why not sooner than too late? And and for example, this is a very limited set of questions. We will not have time to go through these, but this set was to inspire the panelists to give their opening speeches. I will pick here a few, and then we would like the audience to participate. So let's pick the technology, which was touched a little bit already. So if you have to think about the most critical aspect of next generation mobile networks, what would need to be changed from the current ones to ensure networks resilience? Who would like to try to answer that? David.
Thanks. So, is that on? Yeah. Okay. Thanks for the technology perspective. I mean, I say about the example where, you know, the RAN has battery, you know, a power backup. Right? That's the obvious choice. But perhaps in the innovation in 6G, there are other things you can do, such as massive MIMO or something like that. Or how do you gain resilience through satellite backhaul, or, you know, direct to satellite, or direct mode even, you know, addressing the needs of the end user. How can you use sidelink or proximity service device to device? Things like that. That's just an example of today's standards. But what in 6G, what more can we do there? Yeah.
Anybody has any idea or thoughts on if I say that we would need definitely, desperately, a fallback safe mode, which we should switch on to locally when something bad happened? Would that make any sense?
It really would. Yeah. I mean, this is what in public safety they tend to do that now. We tend to have deployables as well. You know, descending out a deployable when the network's out, or some kind of backhaul. So, for example, if a broadband system is out, go back to a lower rate system so that you can at least have a voice call, you know, or something.
Any other thoughts, Aki and Hannu?
Yeah, you said only one, so I have multiple, but you know, related to, I like to talk about multi-RAT, you know, because we have NUTN and TN integration. And so that gives us a redundancy. But, you know, I think this is pretty normal. But getting back to your local, you know, connectivity, I think what is missing today, the local autonomous communication is missing. Because I think many countries, especially in Japan, the small countries, you know, all the connection is going to central places, maybe Tokyo and Osaka, and then it's pretty centralized. Core function is placed there, and it's not distributed. So once you know, some areas got hit, so then, you know, we don't have connectivity anymore. So if natural disaster hits some area, so we should be able to survive in terms of network connectivity, including compute, AI compute. Local autonomy is missing from the current mobile architecture.
Hannu and then Mikko.
Okay, so I was thinking about this kind of architecture AI type, but let me go then in this joint communication and then sensing, because that is then definitely creating the view that network started to be more self-aware, knowing the area, what is quite critical then if we want to have an application like a digital twin, and then also this kind of autonomous driving, etc. So maybe that could be one, but of course that's a need also other things like a terahertz capability behind of that.
Yeah, so the question is quite challenging to like say some one thing, as already in the material that we have been discussing and talking through in this panel, it is obvious that there is quite many different kinds of things that can cause difficulties, challenges with respect to this resilience. And then different approaches in answering the question, so you can think about the probabilities of the different things and what would they cause. And then you can think that what is, if this with certain probability does happen, so what level of impact does it have? And then as a third item, that if you then start addressing that item, like what kind of effort does it take? And Matti, you had also, for example, in the beginning, one nice slide that showed this, that there are different things that you can do on a short term and then medium term, or like short term even immediately, and then medium term, and then also as a longer term research items. And for example, this short term item, you had an example that if you would allow national roaming, so like that is technically then would not be so challenging, and then of course there are then some other challenges with respect to the regulation in making that happen. So as we can see, many different dimensions also there, that it's not only the technical solutions that we are addressing here, and then something that where you have been championing is also to start with to kind of increase the awareness of the importance of this area, helping also then to address this at all of these different levels.
Tommy, do you want to say something before we take questions from audience?
I can do a quick comment. I think, being in academia, that we focus on develop models on correlation effects of different risks. So we know we don't naive on how we design things, and then we can try to do mitigation approaches. But because there are a lot of statistics we could collect already today on different impairments and hazards.
Okay, do we have questions from audience already? Luis always has a question.
Luis Correa from IST University of Lisbon. It's a half a question and a half a statement. Since David mentioned the blackout in Portugal a couple of weeks ago, maybe to give you let me start by saying this. Probably the solution for some of these things are not very complex from the technological viewpoint, but you need to take them into consideration. So I don't want to steal the panel, but just to give you the facts. Out of the 3 operators in Portugal, so we had a blackout for 12 hours on power cuttage, right? And out of the 3 operators, 2 of them, after 1 hour, they were completely down. 1 hour. The third one lasted for 7 to 8 hours, depending on the regions. Now, the 4th operator, if you can put it this way, which is the critical mission one, which is based on Tetra, like you mentioned, they also last only for 1.5 hours. And that's the bad thing, right? Because these were the guys that's supposed to last forever. And the problem was power supply. The batteries, lack of diesel generators not for the commercial operators, but for the mission critical one and all these things. The other thing was that the operators, the commercial operators, were discussing what to do in the base stations. One of them decided to switch off the 5G base stations' active antennas, which, as you know, consumes a lot of power. That's the one that lasted for 7 hours still. So, again, the question/statement. Probably some of the things needs to be incorporated in the design of these new systems is that by default, if there is a power outage or whatever it is, the system reverts to a low-level mode, like you cut high data rates, you cut these, but then you don't need to do these people touching the keyboard somehow, right? The system, the design of the network already incorporates the things so that the system becomes robust and resilient, basically. Sorry if I took the stage.
So, no question.
I said it was more a statement than a question, but do you agree with this? Then it's a question.
I at least fully agree completely, and one thing that also could be thought about in let's say local outage, we might move to mesh networking mode, device-to-device mode, where base stations are used minimally just to control information, coordinate